welcome back. Today's topic is electric dipole. A quick introduction to the electric dipole. In the last video lecture, we have seen how to compute electric potentials due to different charge configurations. In today's class, I hope that by the end of this video lecture, you will be able to explain the concept of dipole and how dipole moment is computed. Moving ahead, most of the times we get a doubt about what do you mean by electric dipole. Electric dipole is a simple couple of opposite charges plus q and minus q which are separated by a distance, a small distance d. Let us suppose there are two charges minus q and plus q which are separated by a distance d. See, this set of charges is called as electric dipole. So electric dipole is just equal and opposite charges which are separated by a simple distance. Normally the direction of this electric dipoles will be from negative charge to positive charge, and the midpoint between these two is basically called as a center of the dipole. The simplest example of where to find these electric dipoles is that you can see an atom basically. An atom is normally considered to be an electric dipole under certain circumstances, that we call it as an atomic dipole, that we will show you. Now you see, we will consider an atom first, okay, rather than a molecule, or we will take it as an atom. An atom basically is a combination of nucleus which is present at the center and a normal states. Nucleus will be present like this. It is a combination of protons and neutrons. It consists of protons and neutrons, right? The protons are positively charged particles, whereas electrons, they will be revolving around here in different orbits. So the electrons will be spread out in different orbits around the nucleus. Under normal conditions, the electrons, the charge which is there on the electrons will be equal to the charge which is there in the nucleus. So under normal conditions, there is no charge. But let us suppose if I apply an electric field, if this atom is subjected to this electric field, then automatically a very strong electric field I am applying here. So automatically what happens, the electrons which are present here, they will be attracted towards this positively charged, whereas this nucleus, it will be attracted towards a negative charge. So assuming that this is going to happen, so automatically what happens, these electrons, they will I assume that the electrons are coming to this direction, whereas so there is a, see here, the center of mass of both the electrons and protons is same, but here the center of mass may be different for both electron cloud and also this nucleus. Now if I write it more precisely, then I can consider it as a negative charge here and a positive charge here. So this is called as an atomic dipole. The amount of negative charge which is present here is equal to the amount of positive charge which is present here, and there is a very minor gap between these two, which cannot be seen by even an atom itself. It cannot be seen by our naked eyes, right? So very small distance between these two. So this concept is called as an atomic dipole. Similarly, a molecule, let us suppose an ionic molecule. Normally it will be having ions, right? So if I take an NaCl, it will be positive charge, it will be negative charge. So if I take a molecule of Na and Cl, if I subject it to, automatically what happens, the chlorine atoms, they will come this side, Cl minus and Na plus, they will move on to this side. So which means that it is an molecular dipole where ions have been formed. If ions are separated, then it's okay. If they are still in the molecule, then this molecule is called as a molecular dipole. So it is a concept of polarization of a neutral material when on the application of electric field. Now, how to visualize electric dipole? As said earlier, electric dipole is nothing but two charges, equal magnitude but opposite in sign, which are separated by a small distance d. And this combined thing is called as electric dipole. Now, this dipole is considered to have some sort of dipole moment. This is predominantly employed in your next lecture problems. So, what is actually dipole moment? Dipole moment is that, normally we have studied in the previous classes, we have gone through some point charges, right? Plus q and plus 2q, plus 3q. Now, all these charges, now let us suppose there is a point is there, each one will be developing an electric field here. Right. Now, if you consider an atom now, if we consider an atomic dipole, now an atomic dipole basically now, if it is represented in this fashion, now let us suppose this indicates electrons which have come here, and this is a nucleus, a little bit distance is there, small distance. Now, if I consider a point, then automatically this will create an impact and this will also create an impact. But technically speaking, this is a single structure, right? So that's why, but single structure but having two charges, negative charge and positive charge, which are separated by a very small distance. So these technical structures are called as dipoles. So physically it is one, but it is exhibiting two charges, and these two charges are internally separated by a small distance. So most of the times all these atoms, molecules, etc., all these, they tend to appear as dipoles. So we need to understand what a dipole is and what a dipole moment is. So what actually is a dipole moment is that dipole moment is considered to be the product of the charge which is present here and the spacing between them. So if let us suppose the charge is plus q and minus q are there, which means that I will consider only q, but it is split as plus q and minus q on the two directions, on the two edges of the item. So and these are separated by a small distance L. So electric dipole moment is given by q into L, the charge which is there and the separation between them. Normally dipole moment is considered to be a vector because it will be having a specific direction. So m is equal to q into L. Now coming to the direction of electric dipole moment, as said earlier, it is a vector quantity, dipole moment, normally represented as my. So it is normally the direction of this dipole moment will be from left to right. This is the convention direction which we follow in physics. But in chemistry, the convention is taken from in the opposite direction normally. It will be from positive to negative. So whatever we take, whether it is positive to negative, negative to positive, what we are supposed to remember is dipole moment is a vector quantity and it will be having a direction. And the line along which this dipole, the direction of this dipole, see, the line along the direction of an electric dipole is called as an axis of the dipole. Okay, so this is the line. Let us suppose this is plus q and minus q. This is the line joining them. So this is the direction, let us suppose. So this is called as an axis of the dipole. Okay, so this is regarding a dipole. I hope you have understood what is the concept of dipole, and I hope that you will be able to explain. So this is a simple question. So a small 1 mark question. What do you understand by dipole, and how is dipole moment determined? In the next video lecture, we will see how any point from this dipole, it will experience the potential and electric field due to this dipole. So let us suppose in the next video lecture, what we will see, we will consider a dipole, a plus q and minus q, a single structure, and we will see what is the voltage and electric field which is created by these oppositely charged particles at a point P. Okay. Thank you. We'll meet in the next class.